Stops to recording is not. Hello students. Yeah. Hello students. Yes guys, yep. I hope now it is clear for you. Just a second. Let me cross check the stop stream once again. I think two are watching now. Hello students. Yeah. Yes guys, yeah. That's very well. Now it's clear for you. Just a second. Let me cross check the stop stream once again. Yes, Faris. Okay, then we'll go ahead with the first part of NCRT. Let us start with the second part of NCRT, which includes mechanical properties of solids, fluids, and heat and thermodynamics, waves and oscillations, etc. So let me start with heat and thermodynamics part. Heat and thermodynamics part. Thermodynamics. The first one is the first more wave process. Okay, you can see the first the highest weightage topic in this is thermodynamic processes, and the next one is heat engine and second law based the problems based on heat engine and second law of thermodynamics. Second law of thermodynamics. So you can say heat engine, heat engine, heat engine, and efficiency of heat engine. Efficiency of heat engine. The other one is the next most important topic from this chapter is the first law of thermodynamics. First law of thermodynamics, guys. So thermodynamic processes including graphs. Actually, the first law of thermodynamics also you have to apply for these different thermodynamic processes like isobaric process, isochoric process, adiabatic process, isothermal process, cyclic process. Okay, all these processes and work done in specifically adiabatic process. In this work done in isothermal and okay, and of course heat engine, when you say the efficiency of heat engine, efficiency eta, okay, and here comes along with this a refrigerator and coefficient of performance of refrigerator also is equal to delta U plus W, or you can say PdV. PdV translated as dQ is equal to du plus PdV, or delta Q is equal to delta U plus PdV or W. So direct questions you may expect based on this, and this first law you have to apply to these different thermodynamic processes based on these graphs, related questions corresponding to these thermodynamic processes also you have gases. In kinetic theory of gases is one of the, you can say, the smallest chapter. Sorry students. Yeah. Gases, monoatomic gas, diatomic gas and triatomic gases. So the concept of degrees of freedom, and calculation of specific heat of different kinds of gases, for monoatomic, diatomic and triatomic gases. So this is one of the very important concepts here, and also different pressure of gas, pressure and kinetic interpretation of gas. These are interrelated. Okay, pressure of a gas, interpretation, kinetic interpretation of temperature based questions, and speeds, different speeds of gases, okay, RMS speed, root mean square speed, okay, most probable speed, average speed, mainly these different speeds. So the expression of different formulae and what is the relation between them, just how to calculate these different speeds in the case of a given gas. So these relations you need to go through once. And I can say is thermal properties of matter. Thermal properties of matter. Right. Yeah, is the live is coming? So yes man, yes guys. Just a second, let me check once. Yeah, I hope it is coming. It is showing blank screen on my, yeah. Yes, now it's coming, yes. Thermal properties of matter. Thermal properties of matter. And second one is thermal expansion. Thermal expansion. Okay. And here you can say again thermal expansion of solids, liquids, expansion of gases, somewhat we deal in KTG. Okay, thermal expansion. And the third one is calorimetry. Okay, law of mixtures also we have to make use here. Thermal expansion, especially thermal expansion of solids. Thermal expansion of solids is very important. Here there we come across the linear, areal and volume expansions. Thermometry. What is here? Different types of thermometers, different kinds of thermometric scales, and how to convert the temperature from one scale to another. That conversion formula you have to just go through, specifically that conversion formula based questions in this particular case. Okay, yeah. Overall, calorimetry is little more important out of all this. Okay, and then thermal expansion. Then you can first weightage you can give to this, and second weightage you can questions based on this. And if you remember direct numericals also, you can answer few questions. So at least the conceptual part also, if you go through, it will fetch you or help you in answering some questions. Next one, this is as part of what you call heat and thermodynamics part. The next one I can say mechanical properties of solids and fluids. Then I will say, then after that let us go through the oscillations and waves part. Mechanical properties of solids, the fourth one. Mechanical properties of solids. Mr. Hamid is coming now. I think the video size I have to reduce little more. It is occupying more space. Alright. Yeah. The mechanical properties of solids. Yes, in mechanical properties of solids, actually mechanical properties of fluids is very lengthy chapter, and relatively compared to that, as it is a small chapter, but you can score very easily the marks from this in examination point of view or in competitive examinations point of view. So what are the topics we have to focus here specifically in solids? Main thing is Hooke's law and Young's modulus. I can say types of moduli. Hooke's law and types of moduli of elasticity. And in types of different moduli of elasticity we come across, you can say Hooke's law. The first one is Hooke's law and moduli of elasticity. Moduli of elasticity. Hooke's moduli of elasticity based questions. In this different moduli of elasticity, we come across different types of moduli. We can say first one is Young's modulus. Young's modulus, and second one is bulk modulus. Bulk modulus and rigidity modulus. Rigidity modulus. Okay, here after this you can say overall this is very important, but here Young's modulus, like more number of questions you can expect than the remaining, and bulk modulus is the next one. But overall this concept you are thorough of elasticity, different formula for different kind of moduli of elasticity and some numericals if you practice. Okay, surely you may come across one question if a question is coming from this chapter. Other than this, we can say the energy stored in a wire. The energy stored in a wire. energy stored in a information which we need to go through. This is about the mechanical properties of solids. It is a very small chapter but very important, guys. And here we have to say stress strain curve based questions. Stress strain curve, stress strain curve, stress strain curve based questions. And the next one is I have to say the mechanical properties of liquids. Mechanical properties of fluids. Mechanical properties of fluids, specifically I can say liquids. Okay, so as already I told, this is relatively a lengthy chapter. Here this we deal with hydrostatics and hydrodynamics, and you can say extension. This four we can do is four subdivisions. In hydrostatics we come across Archimedes principle, Pascal's law, okay, pressure, etc. Okay, hydrostatics, first part is hydrostatics. Under this we come across pressure and thrust. First thing is pressure, liquid pressure also you can call it as, or column pressure. Okay, pressure and thrust. Okay, or liquid column pressure. How to calculate liquid column pressure? If you have a liquid, okay, if it is filled in a beaker to a depth, so what is the pressure here? We call it atmospheric pressure. At a depth I can say pressure. If the liquid is filled to height h, this total pressure can also be called as total pressure or absolute pressure. It is equal to atmospheric pressure plus rho GH. So the difference between these pressures will also be called as Gauss pressure. Okay, based on this questions you may come across here, and as part of hydrostatics. And as part of hydrostatics we have to go through one more concept called Pascal's law and applications. Pascal's law and applications. One of the main important applications of Pascal's law is the hydraulic lift. Okay, hydraulic brakes is one application, and hydraulic lift. This is hydrodynamics. Okay, I have to say, and a very simple relation is equation of continuity. And the second one is Bernoulli's equation based questions and applications of Bernoulli's equation and applications. And in different applications you may come across. One of the very important applications is calculation of speed of a flux. Okay, is very important. Okay, then this is again hydrostatics and hydrodynamics part. The next thing is viscosity. As part of viscosity you have to just go through some concepts like viscous force, and I think this will here it will block this thing, it will block here, right? Coefficient of viscosity. Okay, once again is not displaying here live. Let me check whether it is coming or not. Okay, I can close. Let me. Okay, terminal velocity and Poisson's formula. Poisson's formula, etc. So as part of viscosity, and but here this terminal velocity based questions are a little more important. This concept of terminal velocity we make use in other chapters also. This is some interrelated questions will come here, and the next one is yes guys, I think I have reduced, I have minimized the size of my video. I think now it is still, it's coming same here. I have reduced it, but it is not reflecting. Let me I think this is the minimum, I think guys. Yes. Okay. In the transitions I have not applied, so it is not. Yeah, now you can see. Yes, I guess. Right. Yeah. So that is the next one. That is the next part. The another one is viscosity. Sorry, the next one is surface tension. Surface tension. Here surface tensions, different special cases will come across. Surface tension force and surface tension relation here, and surface energy, surface tension and surface tension force calculation and surface energy calculations. Okay, surface tension force and surface energy calculations and excess pressure calculations. Excess pressure calculations and capillary rays, some basic concepts calculations also. Okay, these are some additional points you have to keep in mind in this particular case. So this is about mechanical properties and mechanical properties of solids and fluids. The next one I can say is the remaining chapters in the second part of NCERT are oscillations and waves. Oscillations and waves. Yeah. The sixth chapter is oscillations. Oscillations chapter, simple pendulum is important part, and is a simple harmonic motion is important. And when you say simple harmonic motion, applications will come. Simple pendulum is one of the applications, and some different other applications also, just like when a liquid is executing a SHM in simple harmonic motion. Not only simple pendulum, spring mass system, if it is executing simple energy of SHM, simple harmonic motion based questions, and specifically some different applications of SHM, as I told you, different other systems other than simple pendulum applications of simple harmonic motion, right? And so here when you say angular simple harmonic motion and a linear simple harmonic motion, these related terms also, simple concepts we have to be thorough in this particular chapter. The next one is waves. Again, waves, you can say relatively compared to oscillations, it is little lengthier one, but one of the points we have to just be more focused here are overall chapter the progressive wave equation, progressive waves, transverse progressive wave means traveling wave equation and basic questions, and then like then stationary waves. stationary waves, specifically in organ pipes and string, both cases. Okay, stationary waves in a string and organ pipes. Organ pipes, when you say closed pipe and open pipe, the velocity of a transverse wave in a string, and velocity of a transverse wave in organ pipes, and as a result frequency of different modes, fundamental mode and other harmonic modes. These points just you have to go through, and comparison related points you have to go through as part of stationary waves, right? Especially in organ pipes and string are more important in this particular case. The next one is beats and Doppler effects. Beats, the basics of beats, and then Doppler effect. Doppler effect is more important, guys. Doppler effect will come across in optics also. Is one of the very, very important concepts, right? Then we can just briefly can go through beats and some other properties of waves, etc. Right? But be thorough these concepts, you can get surely some questions based on this. These are the chapters. I can say you have to focus a little more in the second part of NCERT. First part already I have mentioned, so just you guys can go through those topics which I have discussed. Already it is 10. Now I am winding this. Just if it is required, then we will try to discuss some numericals also based on these concepts quickly.